Section 1.2. In this section we will discover the two topics, exponential exploration and radicals. Let's start with the exponential explorations. Exponential exploration is the exploration of the form a to the m. This means you will multiply the a by itself m times. We have the m factors here. For example, three to the 4 equals 3 times 3 times 3 times 3. We multiply the 3 by itself 4 times, and this is equals a to 1. In the exponential expression, particularly we call the number a here the base of the exponential expressions, and the number m here is called the power of the exponential expression, or sometimes we just call it as an exponent. Let's look at some properties of the exponential numbers or exponential expression. The first one is that a to the 0 always equals to 1, where a is different from 0. The second one is the a to the negative 1 equals 1 over a. Again, in this rule, a should be different from 0. Otherwise, 1 over 0 will be undefined. The third one, if we multiply the two exponential numbers such that their bases are the same, let's say a to the m times a to the n. If the bases are the same, then we write down the common base a, and the new power becomes the sum of the powers of the factors. Let's give an example here for you. Let's multiply the 3 to the 4 times 3 to the 7. And this is equals 3 times 3 times 3 times 3, just because of the 3 to the 4. We have the 4 factors of the 3. And let's say this is the first factor. And due to the 3 to the 7, we have the 7 factors of 3. 1, 2, 3, 4, 5, 6, and 7. So, indeed, what we are doing, we just multiply the 3 by itself. So how many factors we have in total? 1, 2, 3, 4, right? And 5, 6, 7, 8, 9, 10, and 11. Indeed, this is equals to 4 comes from the first parenthesis plus 7 factor comes from the second parenthesis. This is exactly equals 3 to the 11. So if we skip this parenthesis step, it is exactly comes from this product. Just write the new power as a sum of the old powers, 4 plus 7. Let's look at another rule, number 4. If you multiply two exponential numbers, but this time the exponents are the same, m and m, but the bases are different, then you can keep the common exponent here, but the base is going to be the product of the bases, a times b. Another example here for you, 3 to the 4 times 5 to the 4. As you see, the bases are different, but likely the powers are the same. So, under the common power, I write the product of the bases, 3 times 5, and this is equals to 15 to the 4th. Let's continue to look at the other properties of the exponential numbers. The number 5 is going to be division of the exponential numbers. If we divide the two exponential numbers in this ways, if their bases are the same, then write the common base and then subtract the power of the denominator, which is n here, from the power of the numerator. So a to the m minus n. An example for this could be this, like a 3 to the 4 minus 3 to the, let's say 14, 3 to the 14 divided by the 3 to the 7. Then this is equals, write the common base 3 and then numerator of the power of the numerator 14 minus the power of the denominator 7. And this is equals 3 to the 7 again. Number 6 is going to be the power of the power. Okay, if we have the exponential number, but we have the one more exponent or the power above it, then this is going to be a to the m times n. Let me give you another example. 2 to the 4 to the 3. This is like you multiply the 2 to the 4, 2 to the 4, and 2 to the 4 by itself 3 times, right? Because of this 3. Then this is indeed equals 2 to the 4 plus 4 plus 4. And somebody can write this like a 2 to the 3 times 4. So this is equals 2 to the 12. If you just focus on this part and this part, this is exactly the rule 6 what telling us. Okay, let's look at the 7 now. Is the power of the division. If we have a over b to the m, then you can distribute the power m over the numerator and denominator. So it is going to be a to the m over b to the m. So let's look at it. 3/2 to the 2. Then this is going to be 3 squared divided by the 2 squared, and this is 9 over 4. Let's look at the other properties and the last one. Number 8. A over b to the negative 1. If you have a negative power of a function, that means you can flip the function and we get the b over a. A particular one could be this. A over b to the negative m. If you flip the base to the b over a, then the sign of the exponent change, becomes m. Let me give you an example. For example, we have the 1/2 to the 4. Then if I flip the base, okay, let's say this is negative 4. If I flip the base to the 2 over 1, then the sign of the exponent change to the positive, so that this is going to be the, if you divide the 2 by 1, I get the 2 to the 4.